Hello everyone, my name is Komarendra Putra and my friend is Samuel Cornel Simatupang from the School of Computer Science, BINUS University. Today we would like to present our research entitled Mitigation Situational Impairment in DIY Tasks, an empirical evaluation of web-native voice-driven navigation. DIY activities such as cooking, repairing, assembling, and crafting are increasingly learned through web-based tutorials. However, during these activities, users often have their hands occupied by tools or materials. As a result, repeatedly touching the screen to navigate instruction can interrupt the physical task and create interaction friction. Therefore, our study evaluates whether voice-driven navigation can reduce this friction while allowing users to follow web-based tutorial more naturally. Our research focused on three questions. First, how does voice navigation compare with touch navigation in terms of task performance and perceived usability? Second, how reliable in-browser-based voice interaction regarding recognition accuracy and command success? Thirdly, what usability issues and design implications emerge when voice navigation is used to mitigate hand-busy situational impairments? To answer this question, we conduct a within-subject study involving 24 participants, where every participant complete the same task using both touch and voice navigation. To minimize learning effects, we applied in AB or BA counterbalance design. All participants use the same hardware, browser configuration, microphone, and internet connection. We also developed a web-native prototype using the browser speech recognition API. Users could navigate the DIY tutorial using commands such as next step, previous step, show materials, repeat instruction, and such. Next, we present the main evaluation result comparing voice navigation with traditional touch navigation in terms of efficiency, usability, and reliability. Our findings show that voice navigation significantly improves task efficiency. On average, participants complete the total task 29.75 seconds faster when using voice navigation compared to touch navigation. This difference was statistically significant with a p-value of 0.034. This result suggests that reducing repeat manual interaction helps users perform the away task more efficiently.
For perceived usability, the voice condition achieved a system usability scale score of 75.7, while the touch condition scored 63.54. This represents an improvement of 12.19 points, which was also statistically significant. Additionally, 15 out of 24 participants preferred voice navigation for the DIY scenario, indicating that participants generally found voice interaction more comfortable in the hands-busy situation. Regarding reliability, our prototype achieved 87.39 recognition accuracy and the same 87.39% command success rate. Out of 230 available voice interactions, 201 commands were successfully recognized and executed. Most failures occurred because users spoke phrases that were not included in the supported command vocabulary. In other words, the challenge was not recognizing speech itself, but correctly mapping natural language variations to predefined commands. Based on our findings, we identified three important design implications. First, valid command hints should remain visible so users know what they can say. Second, the interface should provide clear visual feedback to indicate whether the system is listening, has recognized the command, or has failed. And finally, the voice interaction should always be supported by touch fallback, allowing users to quickly recover whenever voice recognition does not work as expected. In conclusion, Our study demonstrates that web-native voice-driven navigation is an effective complementary interaction method for hands-busy DIY tasks. It improved both task efficiency and perceived usability while maintaining a high level of reliability. However, voice interaction should complement rather than replace traditional touch interaction. The best user experience is achieved through a multimodal design that combines visible command guidance, clear feedback, and reliable touch fallback mechanisms. Thank you for your attention.
Thank you very much for your attention.